What's up, scholars? Today we're going to talk about solving rational equations. Rational equations are something that has a ratio in it, aka a fraction. All right, so let's equate this to some easier stuff that you used to do back in your Algebra 1 days, solving linear equations. How would we get rid of the fractions in this guy? Well, we can multiply everybody by the lowest common denominator, and that would get rid of these two denominators, so we wouldn't have fractions anymore. What's our lowest common denominator? We got a 5 and a 3 right there. LCD is going to be 15. So let's multiply everybody by 15 and do a little solving. 15 times 2, that's 30 plus, I'm just going to write it out, 15 times 2x over 5 equals 4x over 3 times 15 plus 15 times 3 is 45. Now, why did I do that? So I can easily figure out what I'm crossing out here. 5 and 15, that'll become a 3. And 3 and 15, that'll become a 5. So now we've got 30 plus 3 times 2x is 6x equals 4x times 5 is 20x plus 45. Whew! No more fractions. Sweetie, sweet, sweet. Let's solve that fractionless equation. I'm going to subtract 6x on both sides. Give myself a 30 equals 14x plus 45. Let's subtract 45 on each side. All right, 30 minus, that's negative 15 equals 14x. Dun, dun, dun. Divide by 14 on both sides. X equals negative 15 over 14. How did we get there? We multiplied by the lowest common denominator. So let's do that same idea here with our rational equation. We've got an x in the denominator, making it a rational equation. What's our lowest common denominator? Well, our only denominator here is x. So that's our lowest common denominator. So let's multiply everybody by x, and we get x squared plus 8 times x over x equals 6x. These guys cancel out. So now we've got x squared plus 8 equals 6x. See what I did there? Just moved it right down. If we're going to solve this, first we got to recognize what kind of equation this is. It's a quadratic! Cool. So we need to get this in standard form, meaning let's move the 6x over to the other side. So we got an x squared minus a 6x plus 8 equals 0. This sucker is factorable. Use your ACB tree, or maybe you've just seen this one so many billions of times that you know this becomes x minus 4 and x minus 2. Trying to solve this, so we'll set each of those factors equal to 0. And x minus 2 equals 0. Add 4 to both sides, so x equals 4 is a solution. And x equals 2 is a solution. Great. What do we do to start this off? We multiplied by the lowest common denominator. Now, just like we had when we were adding and subtracting rational expressions, when we're solving, we still got to look for these excluded values. Right? We still can't divide by 0. So we have to pay attention to possibly we will get a numeric solution that's not a real solution. Because when we plug it in, we get a divide by 0 error. So always make sure we're looking at that. So we check out this example number 1. We're going to solve and identify any extraneous solutions. Well, these already actually have the same denominator, don't they? So we could just straight up combine this now. B squared minus 6b plus 8. It's a plus here, so I'm going to put the plus 1 over there. Okay, equals 1/4. So that'll become b squared minus 6b plus 9 over 4b minus, that's a minus 12 equals 1/4. We could actually cross multiply. You could do that if you wanted. Or we could factor this bottom, find our lowest common denominator, solve that way, which is what we were saying we were doing before, so let's just go ahead and stick with it. So our bottom factors to 4 times b minus 3. So our lowest common denominator is going to be 4 times b minus 3, which means we need to multiply everybody by that least common denominator. 4 times b minus 3 and 4 times b minus 3. Right, we're multiplying everybody by that, which is nice here because then that cancels out. And this 4 will cancel out. So we have b squared minus 6b plus 9 equals 1 times b minus 3, b minus 3. So again, we multiply both sides by the lowest common denominator to get rid of that denominator. It also helps us get rid of that denominator. The 4's canceled out. Now, what kind of equation is this again? Oh, that's a quadratic. So let's get it into standard form and then do a little solving action. Okay. Subtract b on both sides. And we're going to add 3 on both sides. Kind of do it in 2 steps at once, but I think you can handle it. So we have b squared minus 7b plus 12 equals 0. You should do your ACB tree. Or you maybe will recognize, because you've seen it a million times, that this factors to b minus 4 and b minus 3 equals 0. Set each factor equal to 0 and solve. So we'll get b equals 4 and b equals 3. But we need to check to see if any of these are extraneous solutions. Let's go back to our original here. Actually, I kind of want to look at this guy, because I can very easily see that one of these solutions is going to be extraneous. If I plug 3 in for b, I would have 4 times 3, which is what? 12. And 12 minus 12 is what? 0! So, b equals 3 is extraneous. Because if we plugged that in, we would get a divide by 0 error. So here's our only real solution, and b equals 3 is an extraneous solution. All right, you guys are doing great. Let's look at example 2. Same idea. Solve it and identify if any of these are extraneous solutions. Okay, so first what do we have to do? Find the lowest common denominator. Got it. How do we do that? Let's do some factoring. Those look like the exact same denominator, so once I factor this denominator, I've factored the other one as well. Factor the top part 2. I've seen that one a million times. I know that's x minus 3 and x plus 1 all over Do your ACB tree. Let's take out a 2 first. And then I'll have x squared minus 7x plus 6. So I'll put that 2 here, so this will factor to x minus 1 and x minus 6. Same thing's going to happen over here. 2 times quantity x minus 1 times x minus 6 minus 1 over x minus 1. Okay, so what's our lowest common denominator? This guy, 2 times x minus 1 times x minus 6. 2 times x minus 1 times x minus 6. Let's multiply everybody by that denominator so we can get rid of it. So we can deal with a regular old solution. Multiply everybody by that lowest common denominator. So 2 times x minus 1, x minus 6, times x minus 3, x plus 1, over 2 times x minus 1, x minus 6, equals 1 over 2 times x minus 1, x minus 6, minus 1 over x minus 1. So I'm just saying we're multiplying every single term by that greatest or least common denominator. When we do that, we will cancel out the denominator on that one and on that one, because we'll have the same on the top and the bottom. So we have x minus 3 times x plus 1 equals 1 minus, we multiply this least common denominator by this fraction. Let me actually write out what's happening. 2 times x minus 1 times x minus 6 times 1 over x minus 1. X minus 1s will cancel. We'll have 2 times x minus 1 times 1. So we'll have 2 times x minus 6. So now we can multiply this out and solve. So again, we multiplied by the least common denominator to every single term. These denominators were our least common denominator. So when we multiplied by the least common denominator, they canceled out. So I just had the numerator left on the left side of the equation, 1 here. And then I actually wrote out what we were multiplying with that last fraction so you could see that x minus 1s were going to cancel. Okay. Now, let's solve it by multiplying that out. X times x is going to be x squared negative 3x plus x minus 3 equals 1 minus 2x plus 12. Combine some like terms. What are we going to get? X squared minus 2x minus 3 equals 1. 1 plus 12 is 13 minus 2x. What kind of equation is this? Yes, it's another quadratic. Okay. So let's get it in standard form and solve. So we're going to add 2x to both sides and subtract 13 from both sides. So we'll have x squared, that will cancel, minus 16 equals 0. Now if you're clever, you see that's a difference of squares, and you know that factors to x plus 4 and x minus 4 equals 0. You set each of those equal to 0 and solve, and you get x equals negative 4, x equals 4. Let's go see if we have any extraneous solutions. If I plug this negative 4 in here, that's not a problem. That's not a problem. That's not a problem, because I don't get any divide by 0 errors. And same thing with the 4. Those are both good solutions. No extraneous solutions on that sucker. All right, do you try problems and show me. Love you.